Okay, so before we talk about the sad story, I just wanted to quickly show some of the pictures that are in your textbook of how this analysis is done. This is a drawing uh, of the original apparatus that was used by the Dutch chemist Kjeldahl to do his analysis. All right, so we have our distillation happening into our HCl over here. And so that's interesting to see. Modern Kjeldahl analysis apparatuses look more like this. It's much more automated. You have multiple food samples you can analyze all at the same time, and the heating all happens on this nice platform here. And here you even have automated titration, right? So that somebody doesn't have to sit there and do the titration by hand, right? So just to show you sort of what this looks like. Now, one assumption that underlies the Kjeldahl analysis is that you're looking at regular food that has normal amounts of nitrogen. But if you have somebody who wants to get around the system, get around this analysis, maybe include less protein, but make it look like you still have the same amount of protein, you just need something that has lots of nitrogen in it. Back in 2007, there were dogs and cats in the United States that were suddenly began to die from kidney failure unexpectedly, and the people couldn't figure out what was causing this at first, and they finally figured out that this was caused by melamine, and one of its metabolic byproducts, cyanuric acid. So these are the chemical structures of these molecules. Now, one thing you might notice about both of these molecules, well, one is made from the other, is that they have very high amounts of nitrogen in them. And the weight percents are listed beneath them. Melamine has a 67% weight percent nitrogen, much higher than your typical amino acid or a typical protein, which has something like 16%, as we said. And so it was discovered that there were factories in China, where it matters, where it happens doesn't particularly matter, but there were factories that were adding melamine to pet food to make it look like it had more protein in it than it actually did. So the manufacturers were cheating the system. Melamine's cheaper than actual protein, and so they wanted it to look like the weight percent looked okay of nitrogen. So that is one limitation of something like this analysis, and something to always be thinking about with your chemical analyses is there are usually some set of underlying assumptions, and there are limitations to your analysis, right? This Kjeldahl analysis does not actually measure protein, it measures nitrogen. And if you have unscrupulous actors like the manufacturers of this pet food, you can cause a lot of harm. What's even more sad about this story, besides the dogs and cats that were dying, is that in 2008, about 300,000 Chinese babies became sick, and at least 6 died from kidney failure. That was also linked to melamine. What happened was that there was milk that had been diluted with water, and melamine was added to it to make the protein content appear normal. And so thankfully, they figured out what was going on there, and there have been safeguards put in place to prevent a similar thing happening in the future. I'm going to put a link up on Moodle as part of this to the FDA. FDA has a web page about this crisis that happened back in 2008 and 2007, 2008 with the pet food in the United States in particular. But this it's a cautionary tale about thinking about analytical processes, thinking about our use objectives, going back to those, and how it's important to remember the underlying assumptions for your analyses, and sometimes it's necessary to do some double checks on things. So sad story to end this chapter, but there are lessons that we can learn as scientists. So hopefully it's useful, and we can avoid situations like this in the future.